Welcome, this is Scott, and this week we're going to talk about consumer optimization theory. Consumer optimization theory is pretty much what it says. As a consumer, you're going around trying to maximize something. Well, what are you trying to maximize? Economists call that something utility, and utility is just another word for happiness. So as I go around, I try and say, well, should I spend my money on going to a movie or going to a restaurant or buying food or buying a car? I need to decide what will make me happiest with my money. So we're going to define what utility is. We're going to define the goal of the consumer. We're going to be talking about total utility, which is sort of my happiness level, and marginal utility, which is the incremental change in my happiness. So if I'm at an 84 units of happiness right now, and you give me a Shamrock Shake, I may say, woohoo, I'm at an 86 level of happiness. My marginal increase went from 84 to 86. I'm 2 units better. If you then punch me and I go from 86 to 80, my marginal utility was -6. It went down. So we're going to talk about total utility, which is your happiness level, and marginal utility, which is the change in utility. And we're going to talk about why consumers have to optimize given they have fixed resources. Now, we've talked about utility theory before in the beginning of the semester. So utility theory is just a way to say that utility is satisfaction or happiness. Seems pretty reasonable that people are going around trying to maximize their happiness. Seems like a reasonable goal. But now what we need to do is we want to quantify utility theory. And what gets hard is that if we were going to quantify, say, the weather, we would use degrees. If we were going to quantify my weight, we would use pounds. If we were going to quantify my height, we would use feet or inches. But we need to quantify happiness. So what we're going to do is we are going to call each unit of utility a util, and that's going to help quantify utility. So you may wonder, well, I know how big a foot is, but I don't know how big a util is. How big is a util? And the surprising thing is it really doesn't matter. A util, what we're going to talk about, is an ordinal construct, not a cardinal construct. So ordinal just means it puts things in order. So an address may help you organize your houses. Room numbers may help you organize. The Dewey Decimal System helps you order things. It doesn't tell you which one is bigger or better. It just helps you rank them. That number is different than a cardinal number. A cardinal number has dimension. So someone who weighs 100 pounds weighs twice as much as someone who weighs 50 pounds. Those numbers have specific meaning. Utils are just order. We'll get into what it tells us and what it doesn't tell us in a second. So let's talk about what this ordinal information means. So let's pretend I would get 10 units of happiness, 10 utils from consuming a Butterfinger and 2 utils from consuming an Almond Joy. So what do you know? Well, because the order 10 is bigger than 2, you know I like Butterfingers more than Almond Joys. But what we can't do is say that 10 is 5 times more than 2, and because of that I would enjoy my Butterfingers 5 times more than Almond Joys. Those numbers have no other meaning besides ranking. That's it. So we're going to be really tempted to use these numbers in a way that we can use them and a way that we can't use them. So for example, if we look at me and we say Scott gets 10 utils from candy and 6 utils from soda, what do we know about Scott? Well, we know that I prefer candy over soda. Then if we look at Ben and we say, all right, Ben gets 5 utils from candy and 7 units from soda. So Ben prefers soda, Scott prefers candy. All right, that we know. What happens if we only have one candy bar? Who should get that candy bar? We're going to be really tempted to just compare these numbers and say, oh, well, Scott gets 8 utils of satisfaction, Ben only gets 5. Let's give it to Scott. So remember that these are ordinal numbers. They may be consistent within a person, but if I ask you how much you would value a candy bar or a soda, you may have a completely different scale of utility, which is completely fine. Your numbers and my numbers are unlikely going to line up exactly. Matter of fact, we assume they don't line up because they're imaginary. So what could have happened? Ben could have just as easily had used these numbers as his utility. Would they have kept the same order for him? Yes, he would still have preferred soda more than candy. So if now we were using these numbers, we would be tempted to say, oh, Ben is going to enjoy that candy bar almost 7 times as much, or 6 to 7 times as much as Scott. But those numbers are just made up. All they're doing is doing ranks. So because of that, we don't use utility to compare across people, because across people, those numbers are meaningless. So next we need to define total utility and marginal utility. So total utility is the total satisfaction you're getting from consuming a particular quantity of goods. It could be from consuming no goods or 1 good or 2 goods or 800 goods. And it's basically saying, what is your level of happiness? How high on that utility mountain are you? Marginal utility is a little bit different. Marginal utility is saying, how much incremental utility did you get from consuming that last or one additional good? So it's your change in utility from consumption. So let's pretend pretend we're looking at the number of ice cream cones I eat. If I eat 0 ice cream cones, I'm getting 0 units of satisfaction from consuming none of them. If I consume 1, I'm now at 30 levels of happiness, and my marginal utility is the change in total utility when I consume 1 more ice cream cone. So in this case, my utility went up by 30. If I have a second ice cream cone, I'm now at a 50 level unit of happiness. But I was already at 30. So my marginal utility is the change from consuming 1 more ice cream cone. So it's 20. So my total utility, the way I like to think about it, total utility is my level of happiness, and my marginal utility is the change in my level of happiness from consuming 1 more consumption. So this is just graphing out total utility, which is the top graph, and marginal utility, which is the bottom graph. Total utility, marginal utility. Total utility is your level of happiness, and your goal is to try and climb that mountain and get as high up on the utility mountain as you possibly can. Marginal utility is decreasing, because that first ice cream cone is really good, but that second ice cream cone didn't provide you the same amount of satisfaction as the first one. This is the law of diminishing marginal utility. So the law of diminishing marginal utility just says that as you consume more and more of a good, it provides you less and less incremental or marginal utility, because the first one is the most beneficial, and then the next one isn't quite as beneficial as the other one. Pizza Hut used to have a $4 incremental pizza. So you'd buy the first one a regular price, then the next one's $4. Or if you go to Disney World, they're the master of this. You pay a high price in the beginning, and then each additional day is a lower and lower price. That first day is where you go to the park you want to go to the most. The second day, you've already gone to that park, so you're picking between another park, which is going to provide you less utility. They recognize that. That's the law of diminishing marginal utility. As you consume more and more, your marginal utility goes down. So if I were to bring my daughter to Disney World, that first day would be awesome. The second day, not as great. By the time I get to the 5th or 6th day, it may be neutral. By the time I get to day 12, 13, 14, it could even be negative. I mean, I could be going insane. The law of diminishing marginal utility can be decreasing. So how do we classify a product? Is it a good or is it a bad? And the way we do it is actually, we talk about what happens to marginal utility. Think about beer, for example. Maybe your first beer provides you positive marginal utility, and your second beer provides you marginal utility, and your third beer. But your fourth beer could be 0. You're not better off, you're not worse off. What happens if marginal utility gets negative? Maybe you're getting sick. Maybe it's become a bad. So what we're going to do is we are going to classify a good based on its marginal utility. If the marginal utility is positive, we call it a good. If it's 0, it's neutral. If it's negative, we call it a bad. So the same good, notice that this is all beer, can be both a good, a bad, and a neutral. So let's build some intuition on consumer maximization. The first one is pretty simple, that if you did not have a limited budget, if you were wealthy, beyond wealthy, no resource constraints whatsoever, you would just go around to every single item and say, does it provide positive marginal utility or not? If it provides positive marginal utility, then by consuming it, my total utility would increase and I'd be slightly happier. So I would just consume absolutely everything that gave me positive marginal utility. That's not the way it really works though. I mean, we all have some budget constraints. So now what we're going to do is we're going to say we're not going to be able to eat everything or consume everything that gives us positive marginal utility. We're going to have to limit it. Now we have to decide how to optimize. And we're going to optimize over the consumption of goods, which are things that provide positive marginal utility. So consumers are going to try and optimize and decide where they're going to spend their money. Well, what they're going to really do is they're going to look at, for all the different goods, and we're going to call A through Z, but really there are billions of goods in the world. We're going to decide, all right, where should I spend my dollar? So we're going to compare the marginal utility that you get per dollar for each good. What this does is it standardizes it, because the more expensive goods provide more total utility, but may not provide the same amount of marginal utility. We want to standardize and get the biggest bang for the dollar for each good. This is going to assume a couple things. One, it's going to assume that all goods are divisible, meaning that you don't have to buy a full car, you could buy a half a car, or you could buy an eighth of a car, or $1 worth of a car. And you may look at that and go, well, that's sort of crazy, but really it helps us with a couple things. It helps us because you could save towards a car, or you could get a loan and do part of a car and do payments of a car. So it helps us to standardize. So how does this work? Think about good A and good B. Good A costs $1 and gives 15 utils, where good B costs $5 and gives 50 utils. Clearly good B is more beneficial to you than good A. However, which one should you buy first? Incrementally, good A is giving you 15 units of satisfaction per dollar, where good B only gives you 10 units. So if you only had $1, you should buy $1's worth of good A because it provides 15 units of satisfaction compared to 10 units of satisfaction per dollar. Giving you the most bang for your buck would be good A for that first dollar. So marginal utility analysis can help us illustrate the law of demand. And we're going to see that on a couple of these graphs going forward in a minute. So let's explain what's going on with equilibrium. So let's pretend for a second the marginal utility of A was you got 20 units of happiness, but it cost you $2, and the marginal utility of B is 10 units and it costs $1. So right now you're in equilibrium. You're spending an equal amount. But now there's a price fall in A. So maybe the price of A down here went from $2 to just $1. Well, what's going to happen? The marginal utility of A per dollar is going to be greater than the marginal utility of B per dollar. So what do you want to do? You want to take some of your resources away from B and start spending them on A because it's now cheaper. You're getting more utility per dollar. So you should shift until these marginal utilities are back equal to each other. As you consume more of A, the marginal utility per dollar is going to fall. As you consume less of B, your marginal utility is going to rise. That's the law of diminishing marginal returns in reverse. So you're going to shift those resources away until they equate out and you'll be remaximizing. So what does a budget constraint look like graphically? Well, it actually looks a lot like what we did in trade theory. So it's going to show graphically all the different combinations of goods and services that you can buy given a set amount of money that you have and given certain prices. We're going to just simplify this and graphically show a budget constraint when you have resources and two goods. And you'll see it's very similar to trade theory. So for this budget constraint, we're going to assume that we have $100. The prices of movies are $10 and the prices of concerts are $20. So what are the various combinations you can use if you're going to spend all your money? And why are we assuming you could spend all your money? We're assuming that these are still goods, so spending your money increases utility. Later on, you can assume that one of the infinite number of goods that's available to you is actually savings. Savings can provide utility as well. So it's just another way of us saying you're going to maximize use of your budget constraint. So with $100 and $10 a movie, you could have bought 10 movies and no concerts. You could have done 5 concerts and no movies, or you could have had any point on the line. You could do a point below the line, but you're not using all your money. You can't get above the line because you don't have the resources to get there, or the prices don't allow you to get there. Just like we had before, if PY is the price on the vertical axis and PX is the price on the horizontal axis, that ratio is going to determine the slope of your budget constraint, PX over PY. It's the relative price of those goods. We'll talk about what can change the budget constraint. If you get more resources, more budget, or less budget, it's going to change what you're able to buy. If the prices change, you're going to have these pivots again, just like we had in trade theory. So if the prices change, let's say the prices get cheaper, you may be able to buy more of one particular good because that price got cheaper and you could purchase more of that good, but it didn't change what you could buy of the other good. So we call that a pivot. So it could be pivot up, pivot down, pivot out, pivot in, just like in trade theory. So if consumers are trying to optimize their utility, we have to understand what their preferences are. And for preferences, we're going to just assume rationality, which is just saying that if you order something, I like Butterfingers more than Almond Joys, more than Kit Kats, you can't then say I like Kit Kats more than Butterfingers. They have to be logically consistent and they have to be transitive, which means you could rank them in order. If you know how some of them work, it's not going to loop on to itself. So if we're going to optimize and we're going to say, here's what your budget is, $100, and here's the utility you get from concerts and the utilities that you get from movies. We want to then figure out the marginal utility you get from each one. Then we want to standardize and get the marginal utility per dollar, and then go and buy the products that gives us the most marginal utility per dollar to optimize. Here's the budget, here's the price, here's the marginal utility. Now we got to standardize it to get the marginal utility per dollar. And then what we're going to do is we are going to look at and say, all right, the first unit of concerts gives us 50 units. units. The first unit of movies gives us 60. If we only had $1, we would buy the movie first because it gives us higher marginal utility. But what we're doing is we're lining these up as two different points where we're spending all of our money. Where would we want to stay at this level right here? The first level, point B, we're getting 50 units of happiness per dollar on the concerts and only 10 for the movies. So we want to take some of our resources from the movies, pull it away, and spend it on the concerts. Buy more concerts and less movies. When we buy more concerts, our marginal utility per dollar on the concert goes down. When we're buying less movies, our marginal utility goes up. But we still are getting more marginal utility per dollar from the concerts, so we're going to spend more money on the concerts and less money on the movies, and now they're equal to each other. So we're going to keep spending to where the marginal utility per dollar is equal across the goods. So graphically, this is just what we did. We started off at a particular point, and then we compared the marginal utility per dollar, and we said, oh, look, the marginal utility per dollar, it's more over here, so we want to take some of our resources there and move it there. So we're going to buy less movies, and more concert tickets, and we are going to move that way, and we're going to keep moving that way until the marginal utility per dollar is equal to each other. If we had started off here, the marginal utility per dollars would have been more on the movies. We would want more movies and less concerts. So we'd do less concerts, more movies, and we would move that way. Either way, we're going to get to that equilibrium spot. Now with this marginal utility approach, we can actually graphically see some of these changes we had talked about, like normal goods and inferior goods. So if your income goes up and you're buying more or less of a good, that's our definition of normal good versus inferior good. So let's visually show what that looks like. This purple line here was what our original budget constraint was. Now, if your budget constraint doubles and you were buying point D and now you are over here, well, what happened? You are now buying less concerts and more movies. If that's the case, then concerts are an inferior good. As your income went up, you're buying less of them. And over here, movies would be a normal good. Well, what about if you went from D to K prime single? Now you are buying less movies and more concerts. So there, concerts are a normal good and movies would be an inferior good. If you move over to K, you're buying more of this good and more of that good. So they're both normal goods. So we could start to visually see, what does it mean to be a normal good or an inferior good when consumers are optimizing given a budget constraint? We could also start to plot out what the demand curve looks like for relative prices. So here, the price of concerts is getting cheaper. If the price of concerts are getting cheaper, it's pivoting out. As the price falls, you could see how many concerts are being purchased. What does that show us? That shows us the law of demand. So in more advanced economic courses, what you'll have is this budget constraint, and then what you'll have are these lines called indifference curves. And these indifference curves are different levels of the utility mountain. So think about them as like a topographical map, and what you're trying to do is touch just the edge and get as far up the mountain as you possibly can with your ladder. When that happens, that budget curve can shift. If your budget curve shifts because you have more resources, then you could buy more stuff. Or if the angle changes because the prices change, well, you're going to start to substitute from one good to another. Well, that is what we call substitution effect. When the prices change and it causes you to shift your purchasing, that's a substitution effect. And I'll show you what it looks like on a graph in a second. The other change that can occur is the income effect. So when your budget constraint shifts out, you have more purchasing power. What you're able to buy changes based on the income effect as well. Your total consumption change is the change from the income effect and the substitution effect based on income and price changes. So these lines right here, those curves, are called indifference curves. You're not really expected to know them at this point, but you see how they have 11 and 12? So this is all the different combinations on that curve that would give you a total utility of 12. These are all the different points that would give you total utility of 11. Because 12 is higher than 11, this is the direction going out where you're going to be happier and happier, which is really just consuming more goods. Okay, that should make sense. Now, let's pretend you started off with this budget constraint, and then what happened? Well, the price of product B got cheaper. So what we're going to first do is we are going to shift the budget constraint and then bring it all the way back to say, well, where would you have consumed at that slope to consume 11 utility? So this is what you're now going to consume more of good B just because it relatively got cheaper. So that's a change in prices. But then your budget actually got better. So then you're going to shift from there to there because now you have more income. Your purchasing power increased. So your overall consumption changed by this much, which is decomposed by a substitution effect and an income effect. So there are lots of ways this model works well and lots of ways where this model trips up students. Right now, it doesn't appear that consumers can save. It appears that you can divide up a car into a million pieces. But really what we're doing is we're going around saying consumers are spending their money $1 at a time, and they're trying to understand, well, should I buy this or should I buy that? And being internally consistent with saying, I know how much more I like Mountain Dew than Mellow Yellow, even though they're very close, I may be able to predict and spend or figure out how I'm optimizing to make myself as happy as possible. And I think it does a good job. I think it explains why musicians are far more likely to buy musical instruments than I am. Why? It would give me no satisfaction to buy a musical instrument that I can't play. So these really allow for individual decision making and individual optimization. And it also got us to derive the demand curve, which is a pretty neat outcome of a utility theory, which is just an ordinal construct and not even a cardinal construct. So I hope you found that interesting. If you have questions, please let me know.